Passenger rail service is our topic in this video. Minasan, konnichiwa, Samurai Engineer desu. Let us continue this topic, and we have the following main discussion. Number 1, intercity passenger rail. Number 2, high-speed passenger rail. And number 3, urban rail transit. So let us have a short description on each of these. In this page, we have intercity passenger rail. These are trains that move passengers between cities. That's why it is called intercities. Long distances and high speed. So this is not for internal city. So intercity from city to city. So this is about what 10 to 20 kilometers, okay, distance. So that is about long distance as they defined it, and they are of higher speed than those trains that are servicing the interior city needs of the passengers. Okay, high-speed passenger rail, short to medium distance intercity rail. Okay, so these are the ones servicing the interior of the city. Okay, short or medium distance for about what 3 to 10 kilometers. Okay, and we have the third one, urban rail transit. So trains that move passengers within a city, urban area, or between the suburbs and the central city. Several types of urban rail transit modes. So in our country, this is more like the MRT, LRT1, LRT2. So they are something like that. Okay. So Amtrak rail network. Okay, so you can see those are the rail tracks of the Amtrak. Amtrak is a corporation that is what operating the Amtrak rail network. Okay, so it connects all of the United States. Connects from what? From Vancouver, Canada on one side, and Montreal on the other side, then Toronto and Montreal on the other side of Canada, and along the border of that Canadian areas, and through Washington, Montana, North Dakota. So those are the states that are actually rural area, mountainous, but icy, snowy. Montana, North Dakota, Minnesota, Wisconsin, Michigan, then Indiana, Ohio. So those are the cold northern part of the United States, and Chicago is one of the big cities, one of the top cities in the United States, unlike the Minnesota part, North Dakota, Montana. Those are the what? I think agricultural and forested parts of the United States. Okay, but Amtrak has a line passing through them. Okay, and these eastern parts are the most developed parts of the United States, including what New Jersey, Maryland, Virginia, New York, Connecticut, and Pennsylvania. So going down to Florida, Orlando, and Miami. So on the south, we have big cities and more temperate climate. Okay, Alabama, Georgia, Louisiana, Texas, okay, New Mexico, Arizona, and in California on the western side. So almost they connect all of the country. Okay. So Australia Express operates in Northeast Corridor, top speed 150. Too much. 150 is about what? Now let us compute. 150 miles per hour is about 150 is about 240. It is about 240. Imagine that, about 240 kilometers per hour. So it is fast. It is fast. Top speed. That is top speed, and the average is about 1/2 a bit. So even 1/2 a bit is 120 to 140 kilometers per hour. It is more than cars. It's more than the speed of a car. Although they can speed up their cars there in their country because the freeway, they have the bigger highways there compared to our country. But 140 kilometers per hour on average, that is nice. Okay, that is nice. So let us okay, average. So you have to deal with it. Average is what? 130. So in our country, we have an average 100 kilometers per hour. 100 is not an average. We have an average of 60 kilometers per hour average, and maximum 100 kilometers in some areas 120. Okay, but usually on our expressway only 100 kilometers per hour. This is 130 kilometers per hour. So another network auto train operates between Virginia and Florida. 855 miles distance. Okay, 17.5 hours, 49 miles per hour. Very smooth and low speed. So this is just what? 80 kilometers per hour. This is still 80 kilometers per hour, still great distance, great speed. We have only 60 in our country. Okay. So, okay, so to train high-speed rail. So, we have a high-speed rail for what? For example, short to medium distances. A rail line is service designed for high-speed operation, cruising speed of 125 plus miles per hour. Okay. Japanese introduced the first high-speed trains in the mid-1960s. Imagine 1960s, Japan made a Shinkansen. Shinkansen is the bullet train. So I personally was able to get on a ride on the bullet train when I am still living in Japan. And very smooth. It's very smooth. Year 2000 or so. Okay, so 1960 they started. So while in Amtrak just crop up their operation year 2000, the turn of the millennium. Okay, so it's about what just more than 20 years. Okay, while Japanese is bullet train 1960s. Okay, today high-speed rail lines are common in France, Germany, Spain, United Kingdom, and many other countries like Taiwan, and Korea. These are called high-speed rail, HSR. Shinkansen bullet train in Japan. This one I happen to write on this one because this is from Yokohama. And as you can see, the background is the Fuji mountain, Mount Fuji, with the snow on top of it. So this is the look of the bullet train. This is not the fastest bullet train in Japan. Okay. Right now, the tested fastest bullet train in Japan is about 600. About 600. Imagine that, about 600. It is almost, it is nearing the speed of airplane. It is nearing the, I am exaggerating, of course. I am exaggerating. It is not near the speed of airplane. Because the speed of airplane, if we are looking at top speed of airplane is about times 2 or times 3 still. But that is the fastest that you can use over railway system. Okay, faster than a sports car. It's faster than sports car is about 300 to 400. That is the sports car. The car racing. Let us we can check the top speed of car racing. Sports car top speed. Okay, so let us check. Sports car top speed is about what? Right now is about Bugatti about 300, no? About 300. So 300 is about what? If we compute 300 miles per hour, that is what? 300 miles per hour is 480. That improved. So my technical knowledge is about 20 years before. 20 years ago. 20 years ago, the top speed of a sports car is about 350. Okay. Now the top speed of a sports car is why there is a top speed for a sports car? It will not breach this. No, that is the top because the tire will be damaged completely in one. For example, 100 meters. Okay, in 100 in one race, in one, what do you call that? One loop. So race car will what? Will proceed with so many loops in a race track. So round. In one round, it will completely damage the tire. Okay, the air tire. Okay, that's the reason. That's why it will not go faster than that. However, the tested safe speed for bullet train right now is about 600. Japan has the fastest bullet train. Okay, so we have this Intercity Express, ICE, Germany. This is the look of it. Okay. Imagine the aerodynamics design. It is the design is almost looking like an airplane. the head of the bullet train looks like an airplane already. Okay, because of the aerodynamic design. That is not yet the fastest right now. This These are the fastest 20 or 10 years ago. Right now, it's about 600 kilometers per hour. Imagine that. You cannot, you cannot overtake this bullet train using your what high-tech and expensive sports car. You cannot overtake this bullet train. Okay, you can try, but you will what? You will eat dust. British rail high-speed trains. They look like it, and I think they are not what aerodynamically designed yet. So I don't expect this to be within 300. This is not within 300. So this is about 200 kilometers per hour. And we have Pratt's TGV. So that is about what? 574. It is tested. Tested 574 kilometers per hour. Imagine that. 574 kilometers per hour. Okay. So, French TGV. So, France, I think, is one of the contender of Japan for what high-speed train research. Okay. That's why we have this type of 574. Imagine Japan 600. So we can look it up. We can look it up currently on our browser. Bullet train top speed. Okay. So Shinkansen, Japan, that is Shinkansen. So this is not yet the current data because this is 2015 maglev. That is the maglev. Okay. Maglev 603 kilometers per hour. That is 2015. Not yet the current one. We still have the current, so about 650. About 650 right now. Shinkansen of Japan. That is the fastest bullet train. So the maglev in Japan. So maglev meaning magnetic levitation. So Shanghai maglev is about 430. So in China. Shanghai maglev. So maglev is magnetic levitation. Actually, the train is not touching the rail. It's not touching because if it touches the rail at that speed, it will burn the wheel. It will burn the wheel. It will melt the metal. It will melt the metal. The melting of metal starts at speed 300. 300 and above, the metal will start to melt. That's why they are what? Using magnetic levitation. Magnetic levitation meaning the train is levitated about 0.3 mm. It is not touching the there is no metal to metal contact already. So actually it looks like an airplane. Theoretically it is an airplane, but it is not having the turbo engine. It is not having the wings, but instead of that, it uses magnetic levitation. That's the difference. So still a very radical improvement to our current practice in railway engineering. High-speed rail in the United States, we have already talked about Amtrak, Acela Express on the Northeast Corridor. Northeast Corridor, meaning on the part of Toronto, Montreal, going down to New York, Boston area. So those are the geographical area being serviced by Sela Express. Several high-speed rail corridors studied. US DOT, meaning Department of Tourism, Federal Railroad Administration, Department of Transportation. In our country, DOT is Department of Tourism. So in this area, they are Department of Transportation, Federal Railroad Administration. Urban rail transit. So let us take a look at rail service in urban application. Operates in city or between the suburbs and central city. So bullet train is for short to long distances. It is not economical. It is not economical. It's very expensive to ride Shinkansen in Japan, where the price of a ticket is too much. But I don't have any alternative because I have going to. I think I have 4 or 5 times. About 4 to 6 times. That is even number because you have to go back using the same system. So about 6 times. I can't remember already. That is about 25 years ago. Okay, bullet train in Japan, very expensive, but compared to airplane, it is still economical. But compared to the common light rail transit on urban rail transit, that is too much. But however, the advantage is to transport goods and people at a very fast speed. Okay. Several types of urban rail transit modes: commuter rail, rail rapid transit, or the metro, and the streetcars and light rail transit. So light rail transit is the type that we are using in our country, where it's usually having the railings above ground. There are some instances that is underground and some instances that is within or on the same level as the ground. But the important thing here is it is fully electric. Okay. But you won't believe that in Japan, there are so many train networks. Okay, there are so many train networks like this in every station. So one station, unlike in our country, about one station, for example, in the one in Cubao, you have the MRT and the LRT 2, and the one in EDSA also have MRT and LRT connection or crossing. But in Japan, not only those, so there are about 10 to 15 different networks, different levels. Okay, different levels meaning, for example, ground, second floor, third floor. There are so many trains passing by, crossing each other, tracks. Okay, so So there are so much happening because of what? So many people that have to be moved from one place to another, probably from their home to the work, home to work and back, and to other what, commercial area and so on. So there's so much happening. Commuter rail looks like this. So we have what? Sorry about that. Sorry about that. Sorry about that. I will get back to you soon. Hey, sorry about that. We're back. And let's continue with this commuter rail, meaning it is mostly for passengers. And we have what, Chicago Metro. I think it's Metro. And Metra is the name of the brand. Okay, so it looks like this, and I think this is engine driven by engine, and plenty of what, rail networks in here. Okay, so about what, how many lines? 1, 2, 3, 4, 5, 6, 7, 8. So about 8, 9. Okay, so about 10. You can see about 10 rail networks going to the Chicago main urban center. Okay, so that's why you can see so many what, rail tracks here. Okay, there are so many rail tracks to that point. No? So yeah, so there are what, plenty of railings. So one after another, there are so many. Okay. So in the same breath, you can see that in Japan there are more than this. In one station, there's too much, particularly in the part of Tokyo and Osaka. So those are the big cities, and Chicago is what, almost the same, in the same. But actually, Tokyo, Osaka is about the same as New York. So in New York, there are plenty of necessity for what? For this, because of density of people working in New York. So that is the same thing happening in Tokyo area of Japan. Okay, so we have here the rail rapid transit to the metro, high speed, high capacity trains, multi-car train operate on short headways. Headways is a technical term for our transportation engineering. Some can operate at 2 minutes or less. That is the headway. Headway is the distance of one train to the next train. So some can operate at 2 minutes or less. Okay, that is a pretty frequent. Okay, so I think in our country, the shortest headway is about 3 minutes. So that is still okay. So 3 minutes is too much. So 3 minutes too much headway for the incoming next train. So and it's not the regular. The most important thing in Japan is they are regular, and their schedule of arrival of trains is very accurate. Very accurate. If they tell you it will arrive in 10 minutes, 40 seconds, they will arrive in 10 minutes, 40 seconds. Plus minus 30 seconds. That is the allowable lateness in their dictionary. 30 seconds is the allowable what, late. Okay, so 31 seconds is already late. 31 seconds already. So yeah, if it is late by 30 seconds, it is still allowed. Okay, acceptable by the public. Okay, so electric power taken from a third rail, exclusive right of way, so underground, elevated, upgrade. So just like in our country, we have part of it elevated, part of it upgrade, part of it underground. But in their country, there are trains that from origin to destination, all underground. From origin to destination, all elevated. From origin to destination, all upgrade. So in our country, from, from origin to destination, you will go underground, elevated, and upgrade. All at the same way. All at the same way, one way. Okay? So our countries to interesting to to apply those things. No? So sophisticated signaling, variety of other names, metro, subway, underground, heavy rail. So those are the terminologies used for this. And we have the again the Chicago area, inner city. Okay, so okay, you can take a look within the Chicago metropolis. There are what about two? There are about two train networks that will what rotate. There is the same thing working like that in what in Tokyo. One is rotating counterclockwise, the other one is rotating clockwise. Okay, you can go back and forth and it will just rotate. If you happen to go sightseeing, you can return back to where you started. You can return back to the same station where you ride on the car, okay, on the train car. Okay? So same thing is happening in Chicago. There are two rail tracks rotating on the metropolis, and there are plentiful of other tracks. 1, 2, 3, 4, 5, 6, 7, 8. So 8, about 8. So there are about 8 train systems passing on this metropolis. Okay. Washington Metro. So the Washington, I think this is Washington DC rather than the Washington State. I think I'm not aware. I'm not aware. I'm just assuming. I'm just guessing it. Light rail transit. So same in our country. A new name for the streetcar. Electrically powered vehicles, but may link two or more vehicles to form a train. So the usage is different from our country. So the usage is different from our country. Okay. So in our country, it is already a train. It is a train, not electrically powered vehicles that may link two or more vehicles to form a train. So already a train in our country. I don't know. I don't know. I don't know the details because you may what. It is about 3 to 6. There are different lengths of LRT in our country. So I think that is about 3 to 6 cars variety of operating strategies, share the road. So it is at grade, like in California. There are what rails on the road, wherein cars, buses could also use at the same time. That space could be used by buses on the same direction, but they are the priority. The trucks has to be used with the priority of light rail transit. So there is a difference in the definition of LRT in our country. Transit only street, transit way, transit mall. So on a separate right of way on the surface, underground or unelevated structure. Typically have honor fare collection. Okay, I don't even know what do you mean by honor fare collection. So honor meaning there is no body who is guarding, who is checking. So like in the buses in Japan, there is nobody who is checking. You will just put your fare on the on some device, and nobody's checking, and mostly they are honest. Mostly they are honest, and up to now there is nobody who is checking that. So that's why they are honest. The same is true is in, I think, in what, in Singapore. Okay, so in the buses, if you ride a bus, no one is checking if you have the correct fare or not. And what? These are the pictures of LRT. LRT. The difference is, in a country, these LRT tracks cannot be used by other modes of transport. In their country, it can be used by other. So buses can also use this one. This one, I think buses can also use it. Or there are special what markings on the road, but there is no what. There is no separation. If it is in our country during traffic, motorbikes, all the cars, taxi will use this area. Okay, so there is no separation. There is no island that could separate one medium of transport from another. They are using the same what, the same space. Okay, using the same space. However, in their area, look, they are not what, congested. This area are not congested. Imagine if that is used in our country. So here, so this is similar in our country. This is more like it in our country. Okay, it's more like it in our country. Okay, but it's just the same. This is just the station, but it's more like it in our country. This is the what, ordinary train in our country. But I think this is what is still light rail because they are electric. Okay, our ordinary trains are, I think, diesel and bunker oil, engine type. Okay, not electric type. Okay, so still plenty of room for improvement in our country. And we have what? Minneapolis, Hiawatha line. So we have plenty of what? Streetcars, electrically powered vehicles that share the road with other traffic. Power is from an overhead wire, trolley, or pantograph. So this is what we are talking about of LRT in our country. They call it streetcars, and they use the same space as with other mode of transport, but the power system is the same because we are using pantograph in our LRT. We have the pantograph overhead. Okay, first demonstrated at exposition in Chicago and Toronto, late 1800s. Okay, several developers, inventors, including Thomas Edison, also called tram. So this is tram in California area. Right. So trolley, street railway, and so on. So streetcars. These are the streetcars. They are using the same space as the other mode of transport. Okay. So the difference is they are using electric power. Streetcars. AGT or Automated Guideway Transit. AGTs. Automated Guideway Transit. So I don't have any idea how this differs from other types. Okay. Automated gateway transit. I don't know. I don't have any idea. I still have to see one of these yet. So AGT, automated gateway transit, is I think more recent than the light rail transit. So downtown people, mover, TPM, several research initiatives in 1980s, three systems built Jacksonville, Miami, and Detroit. So downtown people, mover. So very short. There are two cars only on one train. Okay, sometimes one. I think there's only one car here. But I think they are faster than the usual LRT. Okay, so just like this one, they are faster. They are faster. So it looks like the carnival type of what? It's a roller coaster. They look. I think they operate like a roller coaster. Okay. So automated. Do we say that there's no what? Driver? There's no driver here. And the driver is on the station controlling or the transit. So I don't know. I don't have any idea. There is no additional explanation here. So let us just continue and research about it later. Opportunities. Therefore, let's go to this on the next video. By this time, let us conclude our present discussion on this last page. Thank you again. This is Dr. EYPEI, preaching engineering for nation building.